So now we are going to have a logarithmic equation, which we have three cases in solving the missing value in our logarithmic equation. So there are three cases in solving logarithmic equation. The first case when the missing is the exponent. The second case is the missing is the product. And the third case, the missing is the base. So in logarithmic equation, the common or the a main idea is to convert or transform first the logarithmic into exponential form. So with this one, we are able to solve the missing parts of logarithmic equation. So let's have first this one. If the exponential function is y is equal to b raised to x, then its inverse is x is equal to b raised to y, which is a logarithmic function in the logarithm. So x is equal to b raised to y is commonly written as y is equal to logarithm b, logarithm x base b. So with this one, pinakita lang sa atin how are we going to transform our logarithm into exponential form. So how do we read our logarithm? So we read it as y is equal to logarithm of x base b, or we can have the vice versa. Logarithm of x base b is equal to y. So we should know how to read the logarithm na meron tayo because based on how we read it, we can identify the parts of our logarithm and at the same time the exponential form. So now let's have the logarithm of a number to a certain base is equal to an answer called the exponent. So now let's have the first one. This is the way on how are we going to transform exponential equation to logarithmic equation. But we can proceed already with the case one, which is we are solving the unknown exponent. So in solving the unknown exponent, we are doing the exponential form or the exponential equation. So it is really important that we know the exponential equation because we are going to use this the exponential equation in here in logarithm equation. So with this, we can have the logarithm of 81 base 3, and let's say the 4 is x, which is missing. Then how are we going to solve the value of x? So what are we going to do is transform the logarithm into exponential form. Therefore, we have the base raised to x is equal to 81. And we are going to get the exponential form of 81 which dapat merong same base or same base ni 3. So the exponential form of 81 is 3 raised to 4. Therefore, since they have the same base, we can eliminate the base 3 and copy the exponent x is equal to 4. Therefore, our exponent or the value of x is 4. If there is a need to simplify the value, you need to simplify it. Okay? So now let's have another example with the unknown exponent. So with this one, we have two examples. So the first example is x is equal to logarithm of 8 base 2. So to answer this or to answer the value of x, transform it first into exponential form. So when we transform it into exponential form, we have base which is 2 raised to x is equal to 8. So how are we going to solve this one? Transform 8 into exponential form. Therefore, 2 raised to x is equal to 2 cubed. So since they have the same base, copy the exponent x is equal to 3. Therefore, your value of x or the exponent is 3. And if you can write it into logarithm form, then it is 3 is equal to logarithm of 8 base 2. Now let's have another example, which is x is equal to logarithm of 25 base 5. So we have the base 5 exponent of x is equal to 25. Transform 25 into exponential form. Therefore, we have 5 raised to x is equal to 5 squared. Since they have the same base, copy the exponent x is equal to 2. Therefore, the value of your exponent is 2. So we can write it as 2 is equal to logarithm of 25 base 5. Okay, so this is how easy to solve the missing or unknown exponent. Okay, so this is the first case. Now, we can proceed already with the second case, which is the unknown product. So this one is also easy. Why? Because what are we going to do is still transforming into exponential form, and then you are simplifying the exponential form. Okay, so let's have this example. The example is, let's say the value of x, or the x is the 81. So we have logarithm of x base 3 is equal to 4. So the 81 is the missing. Okay, so what are we going to do is to transform it into exponential form. So we have the base 3 raised to 4 is equal to x. So to find the value of x, we just simplify the 3 raised to 4. So therefore, 3 times 3 times 3 times 3 is equal to 81. Therefore, 3 raised to 4 is equal to 81. So ganito lang po ang pagsosolve ng ating unknown product or unknown number sa ating logarithmic equation. Now, let's have the next example. We have the logarithm example number 5, we have the logarithm of x base 8. Oh, this is equal to 3. Okay, so there's a missing value. So this is equal to 3. So therefore, transform it into exponential form. So when we transform it into exponential form, it becomes 8 raised to 3 is equal to x. And when we solve 8 times 8 times 8, it is equal to 512. So therefore, it is 8 raised to 3 is equal to 512. So this is our missing value or missing product natin. Okay? Next one is we have here logarithm of x base 7 is equal to 6. So again, what do we need to do is to transform a logarithm into exponential form. So therefore, we have 7 raised to 6 is equal to x. And when we solve 7 raised to 6, we have 7 times 7 times 7 times 7 times 7 times 7. So it's supposed to be, it is 6. Then it is x is equal to 117,649, and that is the value of your x. So we have 7 raised to 6 is equal to 117,649. So this is how we solve the unknown product. We just solve or simplify the exponential form that we have in our logarithm equation. Okay, so now we are done with the first case and the second case. Now let's proceed with the third case, which is the unknown base. In the unknown base, we are going to use the law of exponent, which is the radical form, which your exponent will be si reciprocal, o kukunin natin yung reciprocal niya, and then we are multiplying it to the both side of the equation. So therefore, in this one, let's say that the base is missing. Ito pong 3 natin. Let me encircle it. So this one is the missing. Okay, let's say that is the value of, or that is x. Okay, so how are we going to solve the value of x? So what are we going to do is to transform the logarithm of 81 base x is equal to 4 into exponential form. So therefore, we have x raised to 4, x raised to 4 is equal kay 81. So what are we going to do if yung exponent natin is 4, get the reciprocal? The reciprocal of 4 is equal kay 1/4. Therefore, yung 1/4 natin is i-multiply natin in both sides of the equation. So therefore, we have x raised to 4 times the quantity of r raised to 1/4 is equal kay 81 raised to 1/4. Okay? So what are we going to do is simplify. If we have x is equal kay 4 times 1/4, it becomes x raised to 4 over 4, or it is 1. Okay? So, magiging x raised to 1 na lang siya, or x is equal kay 81 raised to 1/4. So, what are we going to do with the fraction or exponent, which is a fraction? So, we will have the radical form of 81 raised to 1/4. So, therefore, si 81 nasa loob ng radical, which is siya yung radicand natin. And yung numerator natin na 1, that would be the exponent of 1. And the denominator of 4, that is the index, which is 4. Now, we need to get the fourth root of 81, which is yung ating 3. So, you can calculate this, or you need to get the root of 81 and multiply it to itself 4 times, then the answer must be 81. And when you get the fourth root of 81, that is equal kay 3. Okay? Now, let's have another example. So, for our next example, we have 3 is equal kay logarithm of 216 base x. So what are we going to do is to transform it into exponential form. So when we transform it into exponential form, we have x raised to 3 is equal to 216. So to get the value of x, or the base x, so what are we going to do is to get the cube root of both sides. So you can already get the cube root. It's based on the exponent. So you can have cube root of x cubed and cube root of 216. So therefore, if they have the same or if the exponent is same with the index, we can cancel it. So the base is equal to x, or the remaining is x, is equal to, and the cube root of 216, you can try with 5 times 5 times 5, that is only 125. Now, let's get more higher. 6 times 6 times 6 is equal to 216. So the value of x is 6. So this is your base. So as we write that, 3 is equal to logarithm of 216 base 6. Okay? Next example natin is this one. The logarithm of 1024 base x is equal to 5. So here we have x raised to 5 is equal to 1024. So we can get already the fifth root of the both side. So fifth root of the both side. So same. Then the remaining is x is equal to. So you can try 5 times 5 times 5 times 5. So dapat 5. That is 3,125. Let's try another. 4 times 4 times 4 times 4 times 4. So, kapag minultiply natin si 4 raised to 5, that is equal kay 1,024. Therefore, the fifth root of 1,024 is 4. So this is the value of your x, or the value of the base. So as we write it, 5 logarithm is equal to logarithm 1024 base 4. So this is how we solve the three cases of a known value in our logarithm equation.